Hello everyone, welcome to IEEE's YouTube channel. Today, I Suhasini will take you through a very beginner-friendly Python project called INSTABOT, which will basically allow you to keep a backup of all the photos and videos that you have posted on your Instagram account or any other account that you want to retrieve the data from. So, for building this project, first you need to open any code editor. It may be VS Code or PyCharm or any other editors that you like. So, I'm using PyCharm here. First, you need to create a folder for your project. Here I've already created the folder called Python project. You can create this by going on file and clicking on new project. Now in this folder, we need to have a file that will basically contain all the code that we are going to write. For this, click on this project folder, go on new, and you'll see an option here called Python file, which is here. Click on this. Now you need to give a name to this file, like I'm giving main.py. Now the first step is done. You have created the file. Now for retrieving the data from the Instagram account, you need to have a package installed for this project. So the package's name is InstaLoader and it will help you retrieve the data and photos and videos from the Instagram account name that you will be providing in this folder. So for installing this, go on to the terminal and write pip install InstaLoader. I already have installed this in my system, so it won't take much time. So here our package is installed. So after installing this package, you need to import this package into your file to be able to use it. Okay, so you'll write here import and the name of the package called InstaLoader. The next step is you need to call this built-in package to be able to use it. So initialize any variable name, like I'm giving insta here, and the name of the package instaloader dot instaloader. Now the next thing is you need to give the name of the account that you want to retrieve the data from. So you can give any variable name. I'm giving ACC for account here, and in quotes write the name of the account that you want to retrieve the data from. I'm giving here IEEE WIVIP, which is our official Instagram handle. Now the next step is we need to execute all we have written. So just type the name of the variable that we have assigned to call our built-in function. So insta dot, you'll see many options here and you can use it based upon your convenience and things what you want to download. Here I want to download the whole profile, so I'll click on download profile, and in this bracket you need to give the name of the variable that's containing your Instagram account name. So IEEE I have stored it in this variable called ACC. So I'll just pass it here. And also, since I need to download the whole profile and not just the profile pic, I'll specify here that profile pic only is equal to false. This will help you download all the things in the profile and not just the profile pic only. Now we are completely done with the coding. Now all you need to do is run this function. So just go here and click on run, and this will start downloading all the files. You can see it's all downloading. Now I'll just stop it here, otherwise it just keeps on downloading and downloading. You can view these files as we go into this folder called PyCharm project, and here you'll see an additional folder named IEEE and here these are all the downloaded files that we have downloaded using that code. Like this is the profile pic. So we are done with this project. I hope you liked it.
Hello everyone, my name is Harika and I'm from WIE. I will be showing you how to build a simple AI in less than 15 minutes. This is super exciting because by the end of the 15 minutes, you will be able to build your first AI and execute it correctly. So the first thing that you want to do, okay, you can see this website, right? So the first thing that you want to do is open a collab page. So you can just go to your Google and type collab Google, and this is a website that pops up. You can click on new notebook, and a new notebook is created. You'll just have to wait for some time for the notebook to be created, and then you'll have to connect your notebook. So what Google does here is that Google Colab is like a great uh, tool to use because you will be writing all of your code here. All you have to do is connect to a runtime, and when you click this, Google gives us for free all of the RAM and data that the space that you need, which is pretty cool. And you can rename the collab, the book, the notebook to AI or any other name. I already made one, so we'll look at this. So we for this AI we'll have to use a data set. So for that, the data set will be in the description box. You can download that and upload it. All you have to do is go to Files, click on the Upload button, and then go to the downloads wherever you have downloaded it, and there's a file with the name cancer. You just have to click on that and open it, and it gets uploaded. So this is the data set we'll be using today for our cancer detection model. Right, you double click on it, you can see the parameters. um, So we have a bunch of numerical attributes relating to different tumors that may or may not be cancerous. And so what we're going to do here is we're going to make an AI figure based out of these parameters and determine whether the tumor is malignant or benign. So, malignant meaning is that the tumor needs to be removed, and benign meaning that the tumor is not cancerous, right? Okay. So here we have label diagnosis one, which means that so we have a naming attribute here which says 1 is equal to M and 0 is equal to B, which means 1 is equal to malignant and 0 is equal to B. So we have 1 here, which means the tumor is malignant, and 0 that the tumor is benign. So for radiologists, this is a very important part of their job because they have to make sure whether or not they're seeing uh, on the mammogram or whether it's actually going to be a malignant tumor. So, having AI help radiologists in this effort is really important and can actually save lives. And we can do this in just a couple of minutes. So, the first step, we've already done it, is to import the dataset, right? And so, what we're going to do is that we're going to import pandas. So I'm going to show it to you here. So you're going to import pandas as PD. And if you don't know what pandas is, it's a library that allows us to do a bunch of cool stuff with data in Python. And then we're going to set our data set equal to pd dot underscore csv, read underscore csv, and the file that we are putting into our environment is called cancer csv. And then we run it. So for running on Google Colab, you just have to press on this button next to it, and it shows you the amount of time in which that part of code has been run, right? Next, what you're gonna do is you're gonna add a cell. So you just have to click on plus code. I already added a cell, so I'm just gonna delete it. Okay, so after you run it, unlike other files, so this is very easy because you just have to type in your code and run it directly and then add another cell. So in Google Colab, you're running the code cell by cell. So, or else you could just to create a new cell, you could just press Shift Enter, and it creates a new cell for you. So now that we know that the part of code is working, this part of the code is working, let's move on to the next part where we have to set X and Y attributes. So the Y attribute that we are, so the X attribute is we're going to drop all the columns of diagnosis. 1 is equal to M, and 0 is equal to B. We have seen that column, right? I'll just show it to you once more. So this is the column that we're gonna drop, right? This is what our X is gonna be. Next, for the Y attribute, we're gonna be wanting to predict whether or not the tumor is malignant or benign, and the X attribute is going to be all of these features, right? And what we're gonna do is we're gonna have to map the AI correlations between these two features, and that will allow the AI to predict whether or not a tumor is malignant or benign. So we're gonna map both of these attributes, right? And so in order to do this, we're going to say that our X is equal to dataset dot drop. And when we're dropping, what we're basically doing is removing a column. So our data set dot drop, and we're going to drop the column which is called diagnosis 1 equals M and 0 equals B close parenthesis. So we're just dropping that particular column from the table. And so with all we've done is that we have our X attribute equal to everything in the data set except for the diagnosis column. So I hope you've understood this. The X attribute is equal to everything in the table except the diagnosis column because we have dropped it, right? Now we'll run this. Yeah, so it runs perfectly. Um, Next, what we're gonna do is so y. Talking about y is equal to data set, and the column is gonna be diagnosis. 1 is equal to M and 0 is equal to B. So we'll just run that. Okay, so now we have our X column and we have our Y column. Let's just close this. And all that's left is to split up our data between I'm so sorry, between a training set and a testing set. So what you'll have to do is split up our data between a training set and a testing set. And this is something that's really important in artificial intelligence because sometimes you'll find algorithms which are overfitting, which means that they do really well on the data that they have seen that's going on in the algorithm. But when you give them new data, they just fall apart. So, in order to mitigate this, what we're going to do is we're going to set a part of our data aside and test it later with our algorithm, right? So the algorithm will be given data that's never seen before, and then we'll use how well it does on the data to evaluate it because that's really what we're looking for, right? not only does the algorithm understand the entire data, but more just the problem in general, which is cancer diagnosis. So, what we're going to do is going to say uh, from sklearn.model selection, we import sklearn. Okay, so we don't have that. Um, it's sklearn is a learn is actually a pretty popular machine learning library. We learn it sklearn because when we import it, and I haven't. So yeah, we'll talk about it in the next series. Probably in the coming videos about sklearn. So what we're gonna do is we're going to say from sklearn.model selection, and so sklearn is um, yeah, so it's actually a very popular machine learning library. You have seen here sklearn dot model selection. So we'll say import test, import train test splits, and then we're going to say x train x test, y train y test, and it's gonna be equal to train underscore test underscore split x, y, and the test size would be zero point 0.2. So basically, 20% of our data is going to be in the testing set. So I hope you understood this code. So scikit-learn is a popular machine learning library, and we use that in the form of sklearn. Just like how we imported pandas as PD, we use it as sklearn, and we import train test split. So as I've said before, we split the data into testing and training data, and then we have variables, that is x train, x test, y train, y test, and we um, equalize them to this. So we only use zero point 0.2. 0.2 indicates that only 20% of our data is being used. All right. Now that's a pretty normal way to divide things up, 80/20. That works, right? Now it's actually the time to build our artificial intelligence, and we're going to be doing this using TensorFlow's Keras, which is again a very popular library. And we're going to be building a neural network, which is a very popular form of artificial intelligence that can be used in almost any problem, and it just sort of adapts to it. So in order to do that, first we're going to import TensorFlow as TF, and we're going to say that our model is equal to tf.keras.models.sequential, right? So let's just run this and see. We've run this. It works completely fine. Now, okay, so now that we have everything, and it looks good, and let's move on to the next step. We need to start adding layers to our module. So if you look up a neural network, what we have here is we have an input layer, which is our x values and all the different attributes of the cancer data set, and then it goes through the hidden layer, and then finally there's a output layer which would tell us if the um, tumor is malign or benignant. So what we're going to do now for this is that we're going to say model dot add tf dot layers dot dense. And so what a dense is, that it's just one of the standard vanilla sort of default neurons that you uh, get in keras. So the number of units you want, we want, and you can see here is that it's just going to be a number, a number which is, I'm so sorry, you're gonna have to, it's gonna be a random power of 2. So I'm going to make this neural network really big than it needs to be. to sort of see how powerful we can get with this data set. So let's say 256, right? And then since this is actually our input layer, so the first layer is the input layer, we need to say the input shape is equal to the x underscore train dot shape, right? And so basically, what we're saying is we're going to input something with the size of x train dot shape, which is to say all of these x features right here, then the output 256 neurons, and then most importantly, we need an activation function, which we're going to set to sigmoid. And basically, the sigmoid function is, if you see on your screen now, we're taking all the values from neural network and we're just plotting them between 0 and 1. And this is going to be very helpful for reducing model complexity and also making the model more accurate. Okay, so now let's add another layer. We'll say model dot add tf dot keras dot layers dot dense. Let's say let's get another 256 neurons and also get the activation function to be sigmoid. And then finally, we make the output layer, which is done in the same way. And we're going to set a value between a single value between 0 and 1 for the diagnosis. So you can understand why sigmoid function can be helpful in that sense. Let's just run this. Okay. We have run it and it's done in like 0 seconds. So it looks like everything ran. It's perfect. Now let's move on. Let's compile our model. So we're going to say model dot compile, and what we need is an optimizer. So the optimizer that we're going to be using is called Adam, and you can see more information about how this works, but this is basically how machine learning algorithm is optimized, how the neurons, how the weights of the algorithm um, are being fine-tuned to fit the data. Next, we're going to have a loss function. So the loss function, because there's the loss function, we use it because we're doing binary classification. We use an algorithm or we use a metric called binary cross entropy. And this is really good when we're talking about categorical data or categorical stuff. So like malignant or benign, they're just discrete values like that. And then finally, we use metrics that we're going to be looking at is we want to look at the accuracy because we want to correctly classify as many tumors as possible. So let's just run this. So this is the part where we compile the model, right? And then, and finally, um, so we'll see. So next what we're going to do is we're going to fit the model, right? So what we're going to say is model dot fit, and we're going to fit our x train of our model to the y train of our model, and we're going to use an epo function. So usually in the first run through the entire data, especially with a smaller data set like this, only about under 600 entries, for 600 entries, the algorithm needs to constantly learn by going over the same data over and over again. So 1,000 epos like this is kind of a lot, but since our data set is small, that's okay. Most likely because of the size of a neural network for the size of the problem. So it's a bit of an overkill, but it's better to be safe. So we're gonna run this, and then while it's running, I'm gonna just take you over a few more things again, if you like that. Okay, you can actually see how um, how the epo is changing and how the algorithm is working and how the output is coming out to be. So we have put like 1,000 epos, and you can see it's going up to 600, 700, right? And it goes up to 1,000. Okay, you were reaching 900, and in no time we'll be at 1,000. Right, perfect. So we have reached our 1,000 apples. So it looks like the accuracy fluctuates quite a bit, but it stays consistently above. Okay, so you can see the accuracy here. It fluctuates quite a bit, but you can see that it stays above 95% for the testing set or the training set. And now for the final thing, all we have to do is to evaluate. So our algorithm is going to say model dot evaluate, and we're going to evaluate the X test. That's our testing set on the Y test. So basically, what this is doing is it's comparing what the model thinks that Y test should be versus Y test actually is. So we'll run that and see that our accuracy. Let's just run it. So we'll run that, and it's just a simple warning. You just have to do something. But let's look at this. Um, it's not pretty serious. When you have an error, it would like show you things in red. So that's pretty serious. You have to correct it. So we see here is that our accuracy is about 97%, which means that on new data, our machine learning algorithm, our AI, can correctly classify cancer diagnosis or cancer tumors with 97% accuracy, which is amazing considering the fact that this algorithm never went to um, never went to college, never went to medical college, and doesn't even know what a tumor is. But from this data, it was able to find a pattern, and from that, it can be used to help radiologists and doctors, right? So that's pretty much it for this video. My friend Suhasini will be showing you another pretty simple tutorial, and you will be able to build amazing things. Thank you.